Now let's move on to the least recently used algorithm, that is LRU. Suppose we have a reference string such as 70542, and we have three frames, frame number 1, frame number 2, frame number 3. Initially, all the frames will be empty, so we load the first three phases, 7, 0, and 5. Now, when the next page comes, that is page number 4, we have to replace one of the pages. So what does LRU tell us is that replace the page which was least recently used. So how do we track that? We have to use indices. So we have to keep a track of last index that the elements in the queue were used for. So in this example, 7 is at index 1, 0 is at index 1, 7 is at index 0, 0 is at index 1, and 5 is at index 2. 5 is at index 2. So out of these indices, the least recently used is the one which has the least value, that is index number 0. So according to LRU, so page number 7 will be replaced since it has the least index out of the pages present in the page frames. Now, say the string is extended with 0 and 5 as well, 7. So we encounter 2. Now the least recently used is page number 0 since it has the least index out of 405. Let us just index them quickly. So now 0 will be replaced with 2, and subsequently 5 will be replaced with 0. So you might ask, what is the difference between FIFO and LRU? The main difference comes when there are pages which are subsequently repetitively used. For example, let us use the new substring or bigger reference string, for example, and let us now add one more frame. So what we will do, let's just clear these up. First four frames will not have any changes, and let us index them. Now once we encounter 0, it's going to be a hit since it is already present in one of the frames. Then we encounter 3. We have to replace, since out of 7, 0, 1, 2, 7 has the least index. So we'll replace 7 with 3. Now when we encounter 0, it's page hit, and then we'll encounter page number 4. Now you will see how LRU is different than FIFO. If it was FIFO, then page number 0 should be replaced since it was added before other pages. But as you can see, page number 0 is again used at index number 6. So out of 1, 0, 1, 2, and 3, you can see that the list index is the one for the page number 1. So page number 1 will be replaced and not as FIFO. Hence, LRU is different with FIFO if a page appears least recently, that is, just before some pages. So, how do we implement this logic? It's pretty simple. We will keep a track of pages present in the page frame and the least appeared index. So it will be page number with a index that it appeared at, the least one. So what is the best data structure for this? It is a hash map. A hash map is nothing like any other data structure. It's very similar to a dictionary if you are familiar with Python. That is, it stores its entries with a key and a value pair. So what do we do is we basically iterate through all the elements in the hash map, which are nothing but the elements that are present in the frames queue, and we find the one with the least index. How do we do that? It's very simple. We make a variable minimum index and then we iterate through all of the indices and set it to the one which has minimum index value. Now let's quickly go through the code. So first we will clone as we did before. Cloning is nothing but copying the pages array into a local pages array so that we do not mess with it. And since we are not actually implementing a queue first in first out, we are using frames queue as a hash set since we do not want duplicate pages in the frames queue. So having that set ensures that there are no duplicate elements. And then we initialize a hash map that keeps track of two integers, that is page number and its respective le least appeared index, that is recently appeared index. So the first logic is pretty similar to the first in first out. We first check if the frames queue is full or not. If it's not full, and if frames queue does not already contain the current page that we are processing, then we add it to the frames queue and then we add the same page to index hash map with its respective index. This would help us to keep track of index and its recently appeared index, that is the one with the greatest value. This will does mean that it was a page fault, that it was not already present. We added it, hence we will increment page fault. This for loop iterates through frames queue and prints it to the console. Else, if the frames queue already contained the page, that means we didn't place it in the queue. It means it was a page hit. And even if it was a page hit, since we have to update the most recent index to the respective page, we have to update our hash map with the latest value. And once the frames queue becomes full, that means it reaches its capacity, we have to perform page replacement using LRU. So first we check if it already contains the page or not. If it does not contain the page, then we initialize two variables. First is minimum index, which is set to a very high value, that is the maximum possible value in the integers data type, and then value to a negative one. So since the index cannot be negative. Now we iterate through the frames queue, and for each element we check its index that was recently appeared. How do we do that? We use the function index hashmap dot get. It will give the value to which the key that we pass in as a parameter is mapped to. So once we send the elements in the frames queue, we'll check its respective most recent appeared index. Then out of all of these indices, what we have to do, if the index is less than the minimum index, we have to update it. We have to set the minimum index to the temporary. This is a very standard way of finding the least element from a list of elements. And then we have to retrieve the value temp as well, since it will be useful, because once we have iterated through all of the elements and we have found the value with the minimum index, we have to remove the page number from the frames queue and then add the new page which we want to add in the first place. That means this was a page fault since we added a new page. So we increment the page fault, we sys out the frames queue. Also, we have to add the new page to the map and its recent index. Else, if it was already present, we did not perform page replacement and we just implemented the page hits counter. That's it for the least recently used algorithm. Thank you.